The stakes are high when drilling and completing a horizontal well. With the risks involved, a complete comprehensive understanding of the drilling and completing process is necessary. Rely on Dowell for the completion of your horizontal well. Horizontal open hole completions begin when the drill bit first encounters the formation. From that point on, every event that occurs can alter the production and life of the well. Dowell offers several reservoir drill-in fluids which meet your formation needs. Our drill-in fluids can be specifically tailored to suit your well conditions and demonstrate minimal formation damage. The formation characteristics and completion technique dictate your reservoir drill-in fluid requirements. Dowell reservoir drill-in fluids have excellent cuttings transport properties. Once the hole is drilled, it is common to leave the hole as clean as possible prior to running the screens. The thin filter cakes are fully acidizable and can be produced back through the sand screen. After the hole is properly conditioned, the screens are run into place. Problems associated with standalone screen completions are minimized when the wellbore collapses onto a properly sized screen and a formation with a uniform sieve distribution. After the formation collapses, a stable production rate is usually observed with very little sign of screen failure, regardless of the screen type. However, there exists a growing amount of evidence that the hole is not collapsing in many wells. In addition, proper screen selection has proven difficult for formations with considerable variance in particle size distribution. In standalone completions, the initial production is fairly uniform. As the production continues, areas of the screen become plugged, forcing the flow to less damaged areas of the wellbore. As plugging continues, the flow is further concentrated in smaller areas of the screens. These hotspots result in excessive pressure drop and increased localized velocities, which result in erosion of the screen and subsequent failure. At best, the screen is plugged, resulting in high drawdown pressures and low production. Gravel packing of horizontal wells presents the opportunity to eliminate costly well failures while reaping the rewards of horizontal completions. One completion method for gravel packing a horizontal well is a high-rate water pack. For a successful high-rate water pack, the wellbore essentially has to be sealed, such that returns can be taken at the toe of the well. Gravel is added at low concentrations and is transported with velocity. As the gravel enters the horizontal annulus, it quickly settles into a low-energy environment, forming a settled bed. As the size of the settled bed increases, a high-energy environment forms along the top of the wellbore, and sand is transported by turbulence. This process quickly forms an increasing front at the angle of repose, which propagates the alpha wave towards the toe of the well. The packing process continues as long as there is enough open area to pass gravel. After the gravel reaches the toe of the well, a beta wave is initiated. The beta wave packs the remaining open area from the toe to the heel, resulting in a successful pack. This packing process can be modeled with SandCage software. Even after a successful high-rate water pack, there is still the task of cleanup of the filter cake, as it may be hindering production. Many operators opt for post-acidizing treatments to enhance production. The major problem with acidizing long intervals is contacting the filter cake. Typically, the acid will wormhole the filter cake in one area, and the rest of the treatment flows into this newly created area of high permeability. All high-rate water packs do not completely pack the entire interval, leaving large areas of screens exposed. These incomplete packs can be caused by areas of high leak-off, which create velocities that are below the critical velocity for gravel transport. This will initiate a premature beta wave. Another leading cause of incomplete packing is when a shale layer is encountered. Typically, the water-sensitive shales will deteriorate after only a short time. This results in shales mixing with the gravel, creating a lower productivity area in the well annulus. Shortly thereafter, the forward movement halts, initiating the beta wave. The combination of ineffective filter cake removal, areas of higher and lower gravel pack conductivity, and incomplete packing all promote water coning. These actions can result in premature water breakthrough and lost hydrocarbon reserves. As a result of the problems that can be associated with high-rate water pack, an alternative method for gravel packing long horizontal wells has been developed. The alternate path technologies were adapted to meet the needs of horizontal applications. This packing procedure is used to successfully gravel pack all wells, regardless of the downhole conditions. To avoid premature bridging associated with viscous carrier fluids, shunt tubes attached to the side of the screens allow an alternate path which bypasses the bridges and continues to pack where voids exist, ensuring a complete pack in horizontal wells. The alternate path technology utilizes viscosity, not velocity, to pack the annulus. Since viscosity is used, the shear rate at the wall is zero. This means that shales can be bypassed, presenting no problems to the completion. Bridges or screen out occurs at areas of high leak-off. The flow of fluid then reverts down through the shunt tubes, bypassing the bridges and completely packing the interval. Since the use of shunts bypass bridges, it is no longer necessary for returns at the toe of the well. This allows for filter cake removal during the packing process. As the filter cake is removed, areas of high leak-off occur, and the sand packs off with the gravel actually acting as a bridging agent, forcing all the fluid flow down through the shunt tubes. This process continues until the entire wellbore is packed. As the well is put on production, the potential for water coning is minimized, resulting in higher production rates and more reserves being produced. With the ability to bypass bridges, the all-pack system can utilize inflatable packers for complete packing at selective intervals. Later in the life of the well, when water coning is present, the coned interval may be isolated and production continued from other intervals. Long horizontal sections can be successfully gravel packed, assuring maximum production and no sand influx. A tight gravel pack is assured over the entire screen length, resulting in minimum drawdown and contributes to a long-lasting completion, eliminating costly workovers.